Hello, this is Mr. Waters, and I'm here to give you a little video about performing symmetry tests. And remember, we're going to perform symmetry tests in a couple of different cases. The first one is where we've got the graph of the equation, and we want to see what kind of symmetry the graph of the equation has. And in the second case, we've only got the equation, and we have to perform the actual symmetry tests. Well, if we've got the graph, or recall that there are three kinds of symmetry that we're going to be interested in. There's the kind of symmetry where when you graph the equation, it's going to look something maybe like that. Oh, it's not very good, but you get the idea. The graph is symmetrical about the y-axis, and we call that y-axis symmetry. In other words, if you were to fold the graph in half over the y-axis, the one side would fall exactly onto the other, and it would look exactly the same. The second kind is called x-axis symmetry, and it's going to look, maybe something like this, okay, where again, it's the idea, in this case, the x-axis forms the symmetry line, and we could fold the graph over the x-axis, and it would look the same. Okay, so that's x-axis symmetry. And for the third was origin symmetry, and I'll label this x-axis there. And the third is origin symmetry, where, and the kind of graph I gave you was a typical one would look maybe something like that, or at least an example of one, okay, where we could rotate the graph 180 degrees around the origin, and it would look exactly the same. We wouldn't be able to tell the difference. Now, if you got a graph of the equation, then it's fairly simple. You simply look at it and see if it has one of those kinds of symmetry lines, and then you label it as having the symmetry or not. Now, of course, lots of kinds of graphs. This one, for instance, straight line, doesn't have any kind of symmetry at all. It's not symmetrical about either the x or the y, and we rotate it about the origin, it won't look the same. So we would say that that is a fine example of none or no symmetry, which is entirely possible. Now, so that's what you would do if you're given a graph and you have to determine what kind of symmetry it is. It's really just a question of looking. Now, on the other hand, what if you've only got the equation? In that case, what you're going to do is you're going to perform the symmetry tests. And the symmetry tests are really pretty simple. So, and there's three symmetry tests, one for each kind of symmetry. So, for example, here we'll put down the y-axis symmetry test. What you will do is, for each time an x appears in the equation, you substitute opposite x. So you substitute opposite x for x, and then you simplify the result. And if the original equation, after simplifying or after appropriate simplifications, looks like the original one, then the equation and the graph of it would have y-axis symmetry. If it does not look the same, if it's even a little bit different, then it does not have y-axis symmetry. Okay, x-axis symmetry, you would the x-axis test for symmetry, you would substitute opposite y in for y wherever you see it, wherever you see a y, and then you simplify, and if the result is the same as the original equation, then that graph, or rather the graph of the equation, would have x-axis symmetry. Okay, for the origin test, you substitute both. Opposite x in for x, opposite y in for y, and if the result, and then you simplify, and if the result after simplification is the same as the original equation, then that graph would have, were you to graph it, you would see that it would have origin symmetry. Okay, so just a couple of examples. Now, if you've got an equation that fails all three of those tests, then you've got an equation that has no symmetry, and that's how we label it as no symmetry. So for example, let's try this one here for x-axis. Y equals to 3x to the fourth power plus 2. I'm going to go ahead and substitute opposite x in for x, and I'll use a different color for that. And so we'll have y is equal to 3 times opposite x to the fourth power plus 2, and opposite x to the fourth power, negative times negative times negative times negative, 4 times cancels out. So after simplification, we end up with, oh yes, the same equation as we started with. And so yes, that's an equation with x-axis symmetry. I mean with y-axis symmetry, sorry. X-axis symmetry, let's try one for x-axis symmetry. Something like, how about this one? X is equal to 2y to the fourth power minus 3. What I'm going to do in here is, I'm like I have in the test up here, we're going to substitute opposite y in for y, leave everything else the same, and then simplify. X is equal to 2 times opposite y to the fourth power minus 3. Opposite y to the fourth power is y to the fourth power. So we end up with, after simplifying, the same equation that we started with. So this equation, were we to graph it, would have x-axis symmetry. And now a third example, how about this one for the origin test? Y is equal to negative 2x cubed. What I'm going to do is, I'm going to go ahead and I'm going to put opposite x in for x, opposite y in for y, and then we'll simplify, and then we'll see. So we'll put opposite y where the y is, negative 2, opposite x in where the x is. Now, of course, you recall that negative times negative times negative is negative, so this negative travels to the outside, cancels out that negative, so we've got opposite y is equal to positive 2x cubed. Now, I'm going to multiply both sides by negative, so we get the y by itself, and that gives us y is equal to negative 2x cubed. And huzzah, that's the same as the original equation there. So after appropriate simplifications, in this case we work to get the y by itself there, it looks the same. Okay, so that one would have origin symmetry. Now we'll do one more here, an example that fails. It's always good to have a failure example. So let's try this one here. Okay, let's try y is equal to x squared plus 2x minus 3. Okay, so let's put origin, let's try the x-axis test, or we'll do the y-axis test first. So we'll put opposite x in for x. So y is equal to opposite x quantity squared plus 2 times opposite x minus 3. So you see I put opposite x wherever we see an x. Okay, we simplify it. That is y equals x squared, because negative times negative is positive. 2 times negative 1 is negative 2x minus 3. Oh yes, that's not the same as the original. You can see, because it's negative 2x rather than minus 2x, and so that fails the origin, that fails the y-axis test. Okay, if we put opposite y in for y, okay, this one's a little bit simpler to do. Okay, now we'll simplify that. We'll get the y by itself so we can compare them directly. So I multiply both sides by a negative. That's going to be y equals opposite x squared minus 2x plus 3. You can see that's completely different than the original one, and so that's not got that's not got x-axis symmetry. And in a similar way, for the origin test, we put opposite y in for y, opposite x in for x. And you can see that this is opposite y, this is x squared, that's minus 2x, that's minus 3. Now, when we multiply both sides by negative to get the y by itself, so we can compare directly, we get y is equal to opposite x squared plus 2x plus 3, not the same as the original, so that one fails. Now, I think we'll do, so that's how it works. Okay, and when you're given an equation and it says test the symmetry, you've got to do all three tests on it. And one of the three will work, and you'll declare that to be the kind of symmetry that it has, or none of the three will work, and you'll state that it has no symmetry of any kind. Anyway, thanks for listening.